Welcome everyone. We're all ready for day 2.
Sorry about that. I'm just cat-proofing my room here. I get the occasional attacker, so I've got to keep them at bay. So how is everyone this morning? All right? Yeah, looking fit and sprightly.
It's great to see some video tiles coming on. That's wonderful.
Yeah. Okay, so the session this morning, which is my favourite part, because now I'm going to listen. Now, I'll answer some questions, of course, but I'm really interested in, what did you think? Because I sort of tricked you yesterday. I started off in the morning saying money has a time value, which is true, and everyone agreed, I think. And then it's like, okay, in that case, bang, 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 all these things that are quite opposite in some cases of the way things are normally done. Now, it's reasonable to stop and check and say, well, hang on a moment. Is this what we want to do? So whenever I get to the end of day 1, or even when I do, one of our sales presentations, a 45-minute meeting with a mining company, and I just give an overview of what I talked about yesterday, I always finish with that red line, blue line slide just to see what the reaction is and saying, so, what do you think? So I'm asking you now, what do you think? So I'd like to hear some comments. If you can put your hand up by clicking on the button to do that. And Stephanie will just select somebody to talk first and we'll work through. But I'd like to hear some comments. What do you think? Is this okay? Is this what we're meant to be doing? Is there something wrong with this? What did you like or not like?
Sure. So just a quick refresher, the raise hand function, you'll find it if you click on the participants button down the bottom, you'll find the option where you can click to raise your hand.
Nobody volunteering a comment yet? Well, let me play back some comments I've had. Oh, there's one.
Wonderful. Tristan,
yeah.
Yeah, maybe I'll get things started.
Thanks.
I have so obviously your capability is really impressive. I've enjoyed this presentation so far. I'm just curious about how sensitive, so for example, you go and you've done your 30-year mine plan, you've optimized grind size and concentrate grade in every period. How sensitive are those decisions to changing economic scenarios? So say, for example, in your case before, if the copper price went up 10%, would you have a massive change in your decisions, or do you normally see those as pretty insensitive?
Yeah, good question. So a 10% change in the metal price, well, what it definitely does is it expands the pit, yeah? Probably by 10%, depends on the ore body. It doesn't have that much difference to where the starter pit, the first phase or the second phase, or the pushbacks would be. Because although the ultimate pit in 20 or 30 years' time gets bigger, definitely, the point at which it's best to do that first cut probably doesn't change much at all. I mean, it may do, but if you ask for some generalizations. Also, if the metal price goes up, definitely the break-even cutoff comes down. But the optimal cutoff doesn't necessarily change much at all, because there are forces that say, well, if the break-even comes down, that's going to drag the optimal cutoff down. But then because the price is higher, that's going to drag the optimal cutoff up. Now, you need to recalculate the optimal cutoff, but it's not moving. Whereas the break-even cutoff will come down 10%, the optimal cutoff might go down 2%, might go up 3%, it might do something. So the answer is a 10% change doesn't make much difference to what you do today if you're running an optimal cutoff and a grind size and everything else. It does add on the end of the life of the mine, of course. Now, if it changes like the gold has changed, 30% or something, well, yeah, that's going to make some difference. I wouldn't presume that you need to do nothing when it's changed 30%. I would be running this analysis again if you hadn't already run this scenario. So, but 10% I don't think makes a lot of difference to what you do today, this year and the next year. Doesn't hurt to check. So I hope that helps.
Yeah, sure. Thanks.
Any other comments or questions?
Next, we have Chris.
Yeah, thanks for that. Is there any time you will compromise or take a reduced MPV for potential share earnings? Because at our company, we've done a PEA, or we've done a couple of PEAs recently, me and Dave, and we're trying to maximize MPV, but ultimately, the company wants to raise capital in the share markets and want to see maximise of the ounces in the ground.
Yeah. Okay. This is interesting. So there is no doubt, and there's been papers written that prove that a company has more reserves, they tend to attract more investor. What you've got particularly in gold, more so in gold than in some other commodities, is people buy shares in a mining company, not because they want the profits of the mining company, they want exposure to the gold. It's quite clear if you want to own gold, don't buy gold because that costs you millions to have a few bars of it. Buy shares in a mining company and you get much better leverage. The gold price goes up, the share price goes up. So there's a lot of people who invest in gold mining companies who know nothing about mining. They just want exposure to the gold. And that group of investors don't know anything about cut-off grades and pit phasing and underground. They don't know anything about that. They just look at how many ounces of gold you have in reserves. And so it is quite clear if you increase your reserves, you may attract a certain type of investor who wants exposure to 2 million ounces of gold, whereas another company's only got 1 million ounces of gold. And they're doing some very silly calculations at looking at the share price per ounce of gold. In other words, how much exposure to gold can they buy? Now, that is a terrible type of analysis because the gold companies with the lowest gold share price relative to their reserves are the ones who have the least profitable reserves. And so if you use that ratio, share price versus ounces in reserve, you're just buying into the worst gold mining companies on the list. But a lot of gold investors in particular don't get that. They don't know anything about mining. And they just want exposure to the ounces. So they look for the ounces, the cheapest ounces, they buy them. So as a mining company, though, and as a board member, you've got a choice. And this applies in any business. You've got a choice of giving the customer what they want or giving the customer what they need. It's in any business. And we're in the same thing. And Whittle Consulting decided a long time, we're going to give the customer what they need, whether they want to hear it or not. That's our policy. But there's many businesses around in all fields saying, no, you've got to give the customer what they want. You've got to delight the customer. So, well, not if it's not in their interests. You know, if I go to the doctor, I want to hear the truth. I don't want him to tell me what I want to hear. It doesn't work that way. And likewise for a board of a gold mining company, do we want to give them reserves because that's what they seem to respond to? In which case you're possibly damaging your company in a true economic sense by putting into reserves all this rubbish that actually drags the MPV down. Or
what about a growth? What about a growth point of view? Because obviously, you know, in the short term, you can maximise your reserve, increase the capital of the company, and potentially, you know, use that, you know, for you know, acquisition of future assets and stuff like that. So there should be sort of trade-off, surely.
There should, but what you're doing is playing to a dysfunctional market. And you can say, oh, but that's the reality, that's the game we've got to play. You can say, well, that's nonsense, I'm not doing that. And that's a personal choice, and you can defend either point of view. Certainly, several years ago, there was a very clear, the papers written on a clear correlation, particularly for gold, between the reserves and the share price. Direct correlation. I think PricewaterhouseCoopers, all sorts of people have done analysis and proven it. I actually think those days are gone. I remember Condor Gold, I'm going to talk about later, where we did some work. They announced a 30% increase in reserves, and there was one trade. And I think that's got to do something to the share price, and the answer was nothing. And then they announced a big increase in MPV, and the share price doubled and tripled. So I'm not sure that correlation directly between the reserves and the share price is as true these days as it was a few years ago, where it's indisputable. And as I say, you've got to decide as a board, you're going to give the market what they want, even though it's, you know, doesn't make any sense, or give them what they need. And that's a valid choice. You were running a business, you want to raise capital. We take the attitude, you know, just pumping up your reserves to you know, it's just window dressing if those reserves are not economic. And I believe you should be maximising economics. That's ultimately what the shareholders will get. Not everyone agrees with what I just said. So it's a choice. So look, running a board, you've got to be practical. I understand that. But so long as you're not fooling yourself as to what you're doing, pump up the reserves. Yes, your share price may go up, but you're attracting a type of investor that is not necessarily the sort of investor you want. But anyway, you've got to raise money. You've got to be practical. So it's a choice. Any other comments? Well, look, let's go back and am I sharing my screen?
We do have a couple more, Gerald.
Okay. Yep, go ahead.
David?
Yep, thanks, Gerald. So referring to the underground method, yesterday you were saying, keep running MSO, increase the cutoff grade, run MSO again, and look at the MPV each time. Can you elaborate more on that method of how you can quickly look and evaluate the MPV without doing a full detailed schedule and financial model?
Right. Well, you need to do a full life of mine schedule, because by presenting so we're dividing the ore body up into zones. So
let's assume, I think most people assume it's a single load, a single load ore body. That's the simplest case.
Okay. So we're looking at one individual zone. Yeah. So you run an MSO, which is a shape. Mm-hmm. It's like a pit shell. And then in a pit shell, you mine it by bench, and you can work out a schedule. In an underground, depending on the mining method, it might be room and pillar, it might be a drive, develop through and retreat, or it might be some initial development, you work your way forward. It might be bottom up, it might be top down. And yeah, ideally, there is no doubt the only way to get it right is to do a detailed schedule. However, when you're in that sort of zone, we're just saying, well, we don't even know if we want to do 1 million tonnes at this cutoff grade or 500,000 tonnes at this cutoff grade. I would argue you can work at a higher level of approximation to zoom in on what you get. Now, the worst way to do it is to take the tonnes and the grades and flatline it. You can see that with 1 million tonnes, it's going to take 18 months, so we'll just flatline it. That's the worst way. To put in some sort of profile that's going to be more development up front, and then the production tonnes can go up, internal development, production, that's even better. And I agree, there is absolutely no substitute for doing an absolutely detailed schedule. But before we go down to, but you've got to be careful, otherwise you're going to commit yourself to do an accurate detailed schedule for every single variation. And if you've got 15 zones and 5, that's 75 detailed schedules. I mean, be great making work for mining consultants. They'll be going for weeks. But I don't believe you need to go to that level of detail to get a feel for where this thing's going. You've got to be able to work at a higher level of approximation to work out that this one's going to be at a 1% cutoff, this one's going to be at a 2.5% cutoff, and then do your details, maybe one either side of that to see. But to say no, it has to be pedantic. So no, it has to be exactly scheduled in detail before we can make any decision. I'm sorry, that's just not true. You can work at a higher level of approximation and zoom in. By the time you get to a conclusion, that must have been done in detail.
Yeah, I guess that's more what I'm asking is the high level approximation, because the more high level you take, the more assumptions you bake into it, and the more distorted from reality you can actually get. So you say don't do a flat line, don't just take the average grade of the whole mine. Okay, but then how exactly do you do it without doing a detailed life of mine schedule? Because as you increase cutoff grade, your cost per mining ton goes up. So even if you did high level, and even if you just assumed a cost per ton as you do in open pit mining, with underground, you got fixed capital development per vertical meter. So every time we increase cutoff grade, our mining cost is actually going up. So that's why, and yet, and then your development will decrease, but not linearly.
Yeah, and in terms of breaking out the components of the costs is the next session, activity-based costing. So you would isolate those, and the vertical development, that's going to be the same whether you take a 1% or 1.5% or 2% cutoff. So you isolate that in your cost model. You don't spread that over the tons you get. And the same with the horizontal development. So you're now down to a zone. Let's take an example. You're either going to take 1 million tons at a 1% cutoff, or you're going to take 750,000 tons at a 1.5% cutoff, or 2% cutoff, 500,000 tons. They're the sort of variations we're looking at. Now, at that level, we don't know if we're taking 1 million tons or 500,000 tons. You do not need a day-by-day schedule of how that exactly works. You'll need that before you operate. But to get a feel of where this is running, I don't see it as any different as running initially some pit shells with average pit slopes. You could say the open pit engineer could be just as pedantic and say, no, but you've got to put berms and ramps. Yes, you do, and you will. But in the meantime, we don't know if the pit's this big or this big. Let's answer that question, and we home in and zoom in. And
I don't mean to be that underground engineer, but
you are.
But there's a natural sequence. So what you're kind of saying is just assume that a tonnage production is happening per day, but that's not the way it operates in underground. To get a schedule that you don't just take the average grade for the whole mine and let it go, you need to physically write rules or sequence every stope to stope, or you don't have a schedule. So you either have a fully sequenced mine or you have no mine and you have an approximation, but you have no idea of the variation of grade that comes out unless you do that sequence. There's no other way. So it is extremely different than open pit in that regard. You can, you're saying on one hand, don't do the high level approximation, but you're saying don't do the detailed schedule. You can't get a schedule without doing the actual sequencing. It doesn't work. It doesn't happen.
You are absolutely right. And you are being that underground engineer says there is no other way in the world you can do anything in your life other than do the detail.
I've been doing it for 15 years.
That's you're absolutely right. Yes, you are absolutely right. And I do find in general, underground mining engineers who are not used to working at levels of approximation are extremely uncomfortable with that. But business modeling in general is always an approximation at some level. And I mean, even when you get down to a weekly schedule, there is still a difference on a day-to-day basis. That's the reality. We all know that. But you've got to be able to, we don't know if we're even going to mine here or not at this stage.
Yep.
We don't know if we're mining 1 million tonnes or 500,000 tonnes. You can use some level of approximation to push you in the right direction. You will do a detailed schedule before you execute it. And inherent in any business modelling exercise is... Sorry?
How does this your Whittle sort of optimization say? Can you maximize the high grade in Deswick, because that's what we do at our company? So in Deswick, maximize the high grade ounces because obviously the mine is heavily sequenced as early as possible, and it's geographically as close to the decline as possible. How does your optimizational tools make that process would be better or more effective process?
Oh, your sound's breaking up, but I think what you're talking about in Deswick, certainly you'll do the detailed design. There is no doubt. In this more...
Sorry, I want to articulate this clearly then. Can you hear me again now? Sorry.
It is breaking up a bit, but have another go, yeah.
Chris, if you have a bad connection from your end, perhaps try turning off your video just while you're asking the question.
Okay. I think what he was trying to ask was actually how does Prober have the ability to tell you what the sequence is of your underground mine to add the best value? So you're picking cutoff grades, but can you go, does it look spatially and pick the high value stopes, like he was saying, easier access, closer to the decline, closer to surface, and actually sequence the mine for you?
Yes, and it does, but at the level of zones. So you divide the ore body up into 10 or 20 or maybe 30 or 40 zones, not 600 individual stopes. And by zone, it'll tell you which order to do these zones and what's cut off of these zones. You will then do the actual detail in Deswick or Mine 24D or Mineshed or whatever you use within that. We're not going inside a zone, we're working at a zone level. Just like when we do pit shells, an engineer will go in and put the berms and the ramps and do all of that detail at a later date. But are you doing it on this pit shell or you're doing it on this pit shell? Are you doing it on this version of the zone? Are you doing it on this version of the zone? It goes to detail design at a certain stage. And the high level work has got to, approximate as accurately as is possible what that end result will look like, but it's okay to be an approximation at that point of time. Not a bland or, uninformed approximation, as well as you can. And this is inherent in any business modeling exercise. is you've got to work at some level of resolution that's and you work your way in. But this is the exercise just with pits, just with underground, to say, well, we don't even know whether we're going to mine here or here, and at what cutoff grade. When you get to that, you're the guys actually can do the detail as how you're going to mine internally to that, and that needs to be done. So it's at a higher level, life of mine, system-wide level that is inherently an approximation of whether it's pits or undergrounds or the plant or anything else. But that can steer you to a place so you do the detail work on what is a better scenario. You need both. This is not a substitute for the detail work. This just guides the detail work. And the ultimate test is when you do the detail work, is it a better plan than the one you had before? And well, our experience is, yes, it is by 20, 30, 40% MPV. Anyway, interesting comments. Appreciate those.
Tapan, you had your hand raised before. Do you still have a question?
Yeah, look, most of questions kind of answered between the discussion between David and Harold. But what I wanted to make a point about is mining is by itself is much more complex operation, whereas we have control on plants, or human can control, but mining by itself is extremely complex, and changing quickly something is so complex. I give you an example. I was working at Andina where blocks on the east-west side could be stiffened in the final pushback, whereas the blocks facing north-south could not be because of wall stability issues. And that added 3 years of life to the mine, to the pit. So those are the kind of complexities we are talking about. So in case of NPV, are you able to really use those inputs to quickly change around these parameters that we have gone through 10 of them yesterday?
So a thing like having different pit slopes in different compass directions, that can, if you know that can go in the pit optimization. There's no problem with that. If you learn that partway through the schedule, which is the sort of reality that happens, I would not be running in every day to rerun the life of mine plan every time you learn something new. I think the life of mine plan should be updated. I think the regular plan should be once a year. Now,
Yep.
After a year, you've learned all sorts of things. You've learned that particular rock type, when you process it, is preg robbing in this, and you've learned that actually you can get a steeper pit slope on this side of the pit. You've learned the gold prices or the copper price has gone up or down. You've learned that you've found and so I would sweep all those changes up, and once a year revise the life of mine plan. Don't every time you learn one thing run another, otherwise you'll end up with 60, 80, 100 runs during the year and you don't know which version you're working with. So inherent in any strategic planning process, and not just in mining, is to batch up changes. And although they might be, you're very excited to see what difference it makes, I would resist that and sweep them up into an iteration, and then another iteration. And certainly once a year, I think, is fundamental. But if you learn something really dramatic, or the copper or gold coal price, whatever, goes some pear-shaped, then that's a reason to actually do something in the meantime. If there's a severe change, positive or negative, rather than say, well, we'll take that into account next October. If it's that material, that would warrant doing some special work.
Thanks.
These issues we're talking about are all just inherent in any sort of strategic planning process, is the ability to work, systematic, to keep the direction. This is the captain of the ship, directing the ship. In the meantime, people are, rowing and beating drums and doing all sorts of things. But you've got to be able to look at a higher level and see what's going on, and that inherently means making some assumptions, some approximations. But it's pointless if you can't get your head out of the detail. Then you can't see the bigger picture. You get immersed in it, and it is hard in a job to flip from one to the other. I totally agree, but that's inherent here. So I think what you're saying is you learn as you go along. Of course you do. I would do iterations. I would do once a year as a minimum. And if something dramatic comes up, positive or negative, we'll do something in the meantime.
Thanks, Sarah.
Okay, thank you. Any other hands up? Otherwise, I can play back some comments that we've had from previous groups. Let me do that a bit and we'll come back to any more questions. So let me share that red line, blue line graph, because I always pause it there. I've had some interesting reactions. So, I show this even at the end of one of my 45-minute presentations. So I visited a gold, I'll talk about gold, it doesn't matter, same commodity, any commodity's got similar characteristics. So I'm in Toronto at a mid-cap gold mining company. I did my presentation and I stop at this. And the mining manager in the room said, very clever, I can see what you're doing, but it's no good. I said, well, why not? He said, look, you've processed all the high-grade ore in the first few years. I'm saying, well, yeah. He said, what happens, the cash flow is getting pretty low from year 8 onwards. What happens if the price of gold go down? You're going to be in trouble because you've only got low grade left. Now think about what he's suggesting, and I've had this actually at board level where people say you shouldn't process all the high grade material now in case the price goes down in the future. Now think about that. If you're nervous that the price is going to go down in the future, all the more reason to process the high grade material now while the price is up. Conserving high grade in case the price goes down does not make sense. You should sell the high grade when the price is up, keep the cash in the bank for the rainy day. I was at an hour later at another gold mining company in Toronto, did the same presentation, got to the same graph. And the guy there said, yeah, I understand what you're doing, but it's, that's not the right thing. It's not good. And I thought, oh, here we go again, same thing. And he said, look, you'll finish this life of mine up in about year 13. What happens if the price of gold goes up? You've missed that opportunity. In other words, the exact opposite argument. And I responded, well, if the price goes up, well, first of all, that's not exactly a problem, but you'll put a 5th pushback on this pit because you didn't put the waste dump and the tailings dam in the wrong spot. You left that option open. You'll go back to your mineralised waste stockpiles that you didn't mix in with the barren waste, and you'll run for another 4 or 5 years. And anyway, are you certain that the gold price will go up or copper price will go up in year 14? I mean, who can predict that? And if you had a reason to absolutely firmly believe it was going to go up in 15 years' time, fine, sit on your resource. Don't mine it. But I don't think anyone can be certain of that. And so therefore, the logical thing to do is to run the red line. So if you think the price is going to go down, you must run the red line plan. If you think the price is going to go up, actually, I would run the red line plan and actually buy options by the junior mining companies, and reinvest that so that you've got your foot on a lot more resource when the price goes up. So I believe, and you can believe anything you like, if you think the price is going down, you run the red line. If you think the price is going up, you run the red line. Why would you do anything else? And the point is you don't know if the price is going up or going down. There's risk. That's the whole point. That is why money has a time value. The only sensible, logical behavior is to put the money in the bank as quickly as possible. What you do with that money, you can invest in other gold stocks, you can invest in copper or whatever you like. That's fine. So what other reactions do we have? Some people think investors don't want this. I've had some people say, oh, yes, but investors want steady cash flow. So no, they don't. They want the money now. If you say, would you like a dividend over the next 10 years or we'll give it all to you in the next 6 months, they will take it. Any investor who says, oh, we're in it for long-term return, I say, no, you're not. You're playing the time value money game. That's the only game you've got. Now, they don't want, when they say they want steady cash flow, what they don't want is unpredictable cash flow. But having variation in the plan and the cash flow, because the ore body is changing, is totally logical. If an investor can't understand that when you go through a high-grade zone, the cash flow goes up, and when you go through a high development or stripping ratio, the cash flow, if they can't understand that, they shouldn't be investing in mining. What they don't want, and they say we want steady cash flow, they don't want steady cash flow. They want the money up front. What they don't want is unpredictable cash flow. They don't like it when you suggest you're going to make a $15 million profit this year and then you make a $15 million. The unpredictability drives them nuts. But if you have a plan that we're going to do this and you deliver that plan, then that's what they mean when they say steady cash flow. The other thing is the belief that what investors want is growth. They want to, if you do an MBA, they say, well, you should be investing in growth stocks. And by front-ending the cash flow like this, inherently the cash flow is going down. Now, you can make growth in cash flow by deliberately performing badly now if you like, but that's just nonsense. That doesn't make sense. And what's not on here is what you're going to do with this investment, with this extra cash. This is the right way to exploit the deposit that you are already working with. But the intention is that you reinvest some of this cash in extra exploration, expansion, acquisitions, and you'll drive this wave forward and up. That's what's not on this graph. This is the economically efficient way to exploit this particular ore body. And the growth comes from doing this consistently over and over and over again. What other comments have we had? We're going to talk later this afternoon about the government's view, the employees' view, and so forth like that. One thing that concerns some people on this particular graph, and nobody's mentioned it yet, is that this red line plan has got a shorter life of mine. Now, the length of the life of the mine is a very socially and politically charged subject. I find it ironic, actually, from an NPV point of view, if you can extract the value from this ore body in 13 years instead of 17 years, I would argue you should. I would argue that the objective is to minimise the life of mine. Let's get in, extract the value, and go and do something else. But there are social, particularly local social and political implications of that. I understand. And we do need to take those into account. Although I find it ironic, when you're trying to get a permit for a mine, the local community are objecting. Yeah, they're out there with placards. 20 years later, when you're trying to close the mine, they're out there with placards objecting. It's the same people. It's just 20 years later. People just don't like any change, a certain extent. And anyway, we'll touch on some of those social political things. Don't get stuck on that, and nobody's raised it. Often people raise that first, because the techniques I've applied yesterday tend to shorten the life of the mine. They tend to bring everything forward, tighten it up, and you've got all those marginal ounces and marginal tons just trimmed out of it. It's a much neater, cleaner, more efficient way of extracting value. But the techniques I'm going to explain in the next 2 to 3 hours, almost invariably, they do that even better, and they extend the life of the mine and increase reserves. In which case, some of those social aspect, or depending on the attitude of the local community, whether they want to mine or whether they don't want to mine, and sometimes they haven't made up their mind, then that gets overtaken. But nobody's mentioned that yet, that this shortened the life of the mine. So anything else? Are we okay with this? Are we basically, and I understand that the concerns are very valid concerns. We have to do this sort of, it's high level modelling. It is as accurate a representation as we can get of the reality of the physical reality, but that's inherent in any modelling exercise. And the ability to work at a superficial level and get more and more detailed as you home in on the right solution. So I'm sorry, I was probably pretty blunt in arguing against those points of view. They're valid points of view, absolutely. And but from an economic point of view, this is absolutely the right thing to do. And some shareholders haven't worked it out. They think they want maximum reserves. I don't think they actually do. I think they want the cash flow now. And they want a long life of mine. So, well, that's fine. Do some more drilling if you want a long life of mine. Don't ruin the ore body already identified by mining it over 20 years when you should have done it in 15. Yeah. So we'd all like, large reserves and long life. Do some more drilling. Don't ruin the ore body you've got. So if we're going to have a whole round of discussion on the government, the community, the employees later on. So if you like, I'll just press on with the next subjects, and feel free to make any other comments during the day by putting your hand up or typing a comment in the side. I'll turn the comments on. While I'm presenting, I tend not to watch them because I'm busy, but I do look at them certainly from time to time, and Stephanie will interrupt me if something comes up. Anyway, I'm convinced in redline mining is the right thing to do, and I'm trying to convince the most of the mining industry in the same thing. So let's go to the next step, because yesterday was the introduction. Now let's get serious. What I did yesterday was explain the 10 mechanisms that apply in an open pit and a slight variation of that in the underground. And those are all valid. So we're not changing those mechanisms. What we're going to do in the next 2 sessions is recalibrate them for activity-based costing and theory constraints. And now that you understand how those mechanisms work, then you're going to see activity-based costing theory constraints, how that takes those mechanisms yesterday to a whole new level. So let me just pull up the next presentation, activity-based costing. There we go. That isn't it. Try again. So activity-based costing. So the next 45 minutes or so, how we got the time, quick time check, Steph, until 10:15. That can't be right. 10:15 till 11:30. Okay, we'll be fine. Yep, got it. Sorry, I'm reading the agenda wrong. Activity-based costing. Yep. Sorry, to what time? Morning tea, 11:30. That's
morning tea, 11:30. Yeah. Did you want to change that time, or is that still
let's go for that. I think we'll be fine. So activity-based costing. Ironically, this is the one subject in the whole 2 days I'm actually qualified in. Everything I've learned about mining has been on the job in the last 20 years, which is quite a long time. This is what I was actually trained in, not originally, in cost modelling, and I learned about this later. Now, if you're going to run a system like we did yesterday, then we've got some very sophisticated software, some very sophisticated mathematics, focusing on cash flow, then obviously the costs that we put into this model are absolutely critical. If we use the wrong costs, or we use just too rough costs, then the answer you get from the software yesterday is just going to be wrong. So this session is to talk about how to model the costs more accurately. And I've got a few funny stories along the way, so I hope you keeps it interesting. So cost modelling is important. If the most important aspect of your life of mine plan is the cash flow it generates, the economic aspects of it, modelling the revenue is relatively simple. You take the grade of the block times the recovery times whatever you think the metal price will be. But modelling the costs of mining, processing and selling it, that's quite a deep subject. And as a general observation, as a cost accountant by training, as a general observation, cost modelling in mining is done quite poorly, which means there's an opportunity. It's the method of actually forecasting or projecting what the costs are going to be in 5, 10, 15 years' time. And if you're running a project, you haven't even got a current operation to look at. But we need to have a view on what those costs, the operating costs, will be in 10 or 15 years' time. Otherwise, on what basis are we going to decide whether to make an investment or not to drive the project forward, and what should the plan be? And I'd argue it's seldom given enough attention. I've seen, in pre-feasibility studies, pre-feasibility study level, if there is loads of cost information, if you get the mining section appendix, you can see the costs, by head count, the tires, the fuel consumption per hour, per equipment type, even the length of the coffee breaks. It's all in there. And if you go to the backup, the appendix on the processing plant, you'll see consumption of reagents by rock type, the power and the liners and the parts and all of. There's a lot of cost information available, even in a pre-feas or a feasibility study. But when you go and look what went in the pit optimization or the stope optimization, it's like mining cost of $3 a tonne and processing cost of $12 a tonne. It's like, well, where did all that information go? And the answer is it didn't end up in the strategic decision-making process. Partly because a mining engineer who's doing the pit optimization may know a fair bit about the mining costs, doesn't know much about the plant costs, probably isn't interested in the plant costs. Even if they were interested in the plant costs, would go and knock on the door of the plant and get the door slammed in their face, let's be honest. So sometimes mining costs are done better in a pit optimization and a cutoff calculation, but the processing costs are normally quite poor. They're averaged, or they're average per rock type or something like that, which is missing a massive opportunity because the deeper understanding exists in the organisation. what we've got to do is dig a bit deeper, get that understanding out and put it into the optimization process that we were doing yesterday. Pits, phase, underground stopes, mine scheduling, cut off, grind size, mass pull, et cetera, et cetera, et cetera. So I'm not suggesting we go out and get lots of people with clipboards and stopwatches doing time and motion studies. Well, you can't in a project. There's nothing to watch. But that we dig deeper into the current understanding that already exists in the organisation and bring that into the optimization process that we went through yesterday. So there are various types of cost accounting. Every business, every company in the world has a financial accountant. This is the boring person. Yep. This is the person, I know that, I'm generalizing and not trying to offend anyone, but I know what everyone thinks. Financial accountant, this dull and boring person, no personality, can't communicate. We keep them in a very dark room with no windows. We sit them on a very high chair with their legs dangling off the floor, with a very low lampshade over their head, and they have to wear a visor to stop that light reflecting in their very thick glasses. And you can just imagine this poor sod sitting in this room and it doesn't talk to anybody, and nobody wants to talk to them. And we throw all the paperwork at this poor person and we say, account for the costs. Now, they don't know anything about the outside world because we never let them out. And so they look at the invoices or the delivery receipts and they say, okay, so they will group the costs according to what we purchased. So the general ledger system, the primary accounting system in the business is basically a purchasing system, and it records what did we purchase. And it'll be labor, diesel, electricity, parts, consumables, whatever. In other words, what did we purchase? And the financial accountant can tell you to the cent how much we spent on diesel or labor or electricity last month or last year. Got no idea what it was used for, but they know what came into the business, what we paid for. The next thing is we have management accountants. Now, management accountants, and there aren't many management accountants in the mining industry. It seems to be a profession that's missing. A management accountant understands the business. They wear a suit, a tie, and they walk around. They talk to management all the time. They do management presentations, much more interesting people. I'm a management accountant, in case you didn't notice. Their primary function is responsibility accounting, because they're interested in making sure we control and manage the costs. Now, most companies in the world, not just mining, the CEO delegates authority according to the organisation structure. Each departmental manager, so in mining that would be geology, mining operations, plant, technical services, HR, they would propose their cost budget for the next 12 months. That would get discussed and approved, and then you have a budget. Now, it's the management accountant who checks that you stay within your budget over the next 12 months. They would police that, and they would see, and if you're going over budget or you're under budget, they would do some analysis as to why, make sure that we're actually managing the costs in line with the plan. It's responsibility accounting. Who's responsible for that cost? Now, that's a step in the right direction, because in monitoring the cost, they may have some understanding of the business and what makes costs go up and down. But what we're doing here for this strategic planning purpose, so I'm talking about cost modelling for yesterday's purpose, and I'm pointing here because that sheet I've got there is just in front of my hand. So when I point here, I'm talking about that 10-step exercise we did yesterday. This is not accounting, and we've got to drop the accounting term. This is modelling, and that's a different thing. Now, it's got to be accounted for eventually. We know, of course it does, but it's a modelling exercise. And so we've got to drop our accountant's mentality and start talking about being a business modeller. We're interested in why the costs are what they are. What makes the cost go up and down? What makes the cost behave? And that way we have a chance of predicting what the cost will be in the future in 2 or 5 or 10 years' time, when the business is completely different from what we're doing today. And in a project, we don't even have a business today. We've got this imaginary business running in the future. So let me go back in time, and I've got some funny stories. So my first job when I graduated is I went to General Motors Holdens in Australia, Fisherman's Bend. And I joined the finance department. This is 1980, I think. So I'm giving away how old I am. And it was fascinating. There were 25,000 employees at General Motors in Australia, 1,000 of them in finance. Can you imagine 1,000 accountants? How exciting. And there was a whole finance building, 3 floors on the edge of Lorimer Street and Salmon Street. Any Victorian would know that, near the Yarra River. And there was 1,000 finance people in there, and I was one of them. Now, being the junior management accountant, I sat in the front row, had a big room with rows of desks. And I sat in the front because my supervisor sat 3 desks back, and they could watch me and supervise me and make sure I was doing my job. Now, this is in the days when a spreadsheet was a piece of paper this big. We didn't have Lotus or Excel or even VisiCalc, only came in the mid-80s. And I had a pencil. Where's my pencil? And although I had a university degree, I had a mullet haircut in the 80s. That's the fashion, a bit short on top, long at the back. I had a university degree, mullet haircut, 3-piece suit. We used to dress up in management accounting, and a pencil. I spent most of my time just doing arithmetic on a piece of paper, just basically multiplying numbers out and adding them down and across, because we didn't even have calculators. Calculators in those days were those Hewlett-Packard things where you had to enter X, enter Y, and then add X and Y to get an answer. And to do the sort of arithmetic we were doing, it'd be hopeless. So we were literally doing additions and multiplications by hand with a university degree. Could have had monkeys doing this job, but that's what we used to do. Now, I've got to tell you a funny story just to set the scene so you can. It's more like the 60s than the 80s, but this is the 80s of General Motors. Funny thing happened. The company had financial trouble. They put in an employee suggestion scheme. And this is where any employee, and 25,000 employees who came up with a suggestion that would reduce the costs of the company, would be given a cash prize. Now, the guys in engineering and in operations were cleaning up on this, all sorts of suggestions coming in, saving thousands of dollars. And they were getting paid hundreds of dollars or even more for those suggestions. But if you're sitting in the accounting department, the management accounting department, what could you suggest to reduce costs? Now, the guy next to me won $1,000 for this suggestion. And his suggestion was, sharpen your pencil at both ends. Seriously, this is how accountants think. Yeah. You say, well, what are you talking about? Now, we've got 1,000 people sitting there with pencils working away, getting up 6 times a day. He'd measured it to walk to the front of the room to use the pencil sharpener that's bolted to the desk. If you could reduce that to 3 times a day, even though the time at the pencil sharpener would be longer, the walking time would be less, everyone's on overtime. It's tens of thousands of dollars a month saved by sharpening your pencil at both ends. Never thought of giving you 2 pencils. Yeah. In fact, I couldn't get a new pencil until I handed my old pencil back, and it was less than 2 3/4 inches long. That's how accountants think. Yeah. So you can imagine us sitting there crunching numbers away. And we had a costing manual that was about this thick. It was from the head office in Detroit. And I didn't even have to think. I don't know why they had graduates. But anyway, I just looked up the costs. We had all the cost codes there. And there were 3 categories of costs. And the first one was capital costs. So if General Motors bought a machine or built a new factory, or in a mine, if you buy a new excavator or a new dump truck, you don't put that cost on the profit and loss statement. Otherwise, every time you bought a new piece of equipment, it would make it look like you made a loss. And that's not right. So what you do is you put the capital costs on the balance sheet as an asset, and you depreciate them. You amortize them over 2 or 5 or 10 years over the useful life. So you put your $1 million or $5 million, and it trickles through year by year, month by month. That's how you deal with the capital costs. The next one is fixed costs. So there's certain costs that don't change. So production might go up and down from month to month or year to year, but there's some costs that don't move. They're called fixed costs. And then we have variable costs. These are the ones that do go up and down as production goes up and down by month or by year. And so I looked myself up. I thought, what am I? Cost analysis in the head office, cost analyst, sorry. And I was a fixed head. And I looked up the factory manager, and he was a fixed head too. And I looked up a machine operator, and they were a variable head. Because at least in theory, in our cost model, we presume that if you make more or less cars, you need more or less operators, but you still need a factory manager regardless, and you still need a cost analyst. And I think in mining, we've still got this terminology. That's a capital cost, we've got a fixed cost, we've got a variable cost. You do more tons or less tons. Some costs go up and down, some costs stay exactly the same. So let's give that a go in mining. Now, in a room like this, maybe just do a thumbs up or if you agree, and down. For the few faces I can see, that's fine. So truck maintenance, this is regular servicing. Is that a fixed cost or a variable cost? Who says fixed? Can't see anyone. Who says variable? Quite a few hands going up. Okay. So the more you drive the truck, the more often you got to service it. Fine. And that's the attitude I take with my Land Cruiser. Every 10,000 kilometres, I take it for service. But once in a while, that Toyota mechanic, who I really don't trust, says, oh, you've got to change the brake fluid and the transmission oil. I said, what for? I've hardly driven it in the last 12 months. I've been travelling. He said, oh, because it's a certain time has come up and it deteriorates and whatever. So I'm sure for a truck, there are some parts that need to be changed over a certain time period as opposed to on the number of operating hours. And also, if you have a maintenance department with 20 permanent employees, then that portion of the total maintenance cost is going to be fixed, isn't it? So you could argue that maybe some of the maintenance cost is at least fixed and a lot of it's variable, changing the oil and the tyres and the filters. We don't have to agree on this. What about the diesel consumed by the truck? Is that fixed or is it variable? Who says fixed? No one? Who says variable? Most people. Okay, and I think that's right. The more you drive, the more diesel you consume, the less you drive, the less diesel you consume. And for a dump truck, I think that's quite right. But what about the watering truck? What about the truck that is driving up and down the ramps, sprinkling water on the ramp to keep the dust down? You could argue that the diesel for that truck is a fixed cost because that truck has to operate whether production's up or down this month. It's got to do the same amount of watering, or maybe it varies on the season of the year. But it's not on the production tons, is it? So you could say, well, the dump truck is variable diesel consumption, but the watering truck is actually a fixed consumption because you've got to do it anyway, whether mine production's up or down. You could argue that. What about the wages of the driver of the truck? Fixed or variable? Anyone says variable? Anyone says fixed? Got a couple of hands, a lot of people not sure because it's not that clear, is it? Depends on the contract. Depends on the location. There might be some legislation. Can you hire and fire drivers month to month, day to day, year to year? So it also depends on what time frame you're talking about as to whether it's fixed or variable. If people all turn up for work this afternoon, you've got to pay them. That's a fixed cost. Now, maybe in some locations you could vary the head count of the truck drivers from month to month, but in a lot of places that would be impossible. But hopefully you can change it from year to year, by some attrition level or, and hiring more people. So it depends on where you are, depends on the contracts, and it depends on what time period you're talking about as to whether it's variable or whether it's actually fixed. It's not that clear, is it? What about the power consumed by the mill? Is that fixed or is it variable? Who says fixed? No one? Who says variable? Oh, I saw one. Who says variable? A few hands going up. See, people get hesitant. It's not that clear, is it? Now, you could argue that the mill, well, depends on how many tons we process. The more tons you process in a year, the more power you use. The less tons, the less power you use. But the mill is probably going to be the bottleneck in the system. Therefore, it will be running flat out all the time. So is that a variable cost that is fully utilised? Or is it therefore, because it's fully utilised, therefore a constant amount, does that make it a fixed cost? You could argue either way, couldn't you? And does it make any difference if you call it a fixed cost or a variable cost, if in fact it's fully utilised and it's the same number all the time? This is not that clear. Acid, oxygen, reagent, whatever your reagent is that fixed or variable? Most people say variable, but it's probably variable on the chemistry of the rock, not just variable on the tonnage of the rock. And I happen to know, having done a lot of work in nickel laterites, that the acid consumption in a high pressure leach is dependent not on the tons, or not only on the tons, but on the nickel, the cobalt and the magnesium grade. So it's dependent more on the chemistry. But also there's about 10 or 15% of acid put into the system, regardless of what rock you're going to actually process and the grades of the rock. You put in an additional amount of free acid contribution to accelerate the rate of reaction. You could argue that that component is fixed. So this is not a very good system, is it? So time's a consideration. Now, what we're talking about in the strategic planning sense, what I was doing yesterday is, what the costs are going to vary from year to year. If you're doing monthly reporting, then you're interested in what's going to vary from month to month, what's fixed and variable. That's what I was doing back at General Motors. What happens if you change the structure of the business? Let's say you double the size of the mining fleet, or you add a second ball mill or something like that. What happens to your fixed costs? And most people would answer, well, if you double the size of the fleet, then the fixed costs associated with mining are going to go up. How many times have you uttered those words? How many times have you actually said, if you do that, your fixed costs will change? Therefore, they're not fixed, are they? They're just dependent on something else that we haven't necessarily named yet. And it's maybe not production tons, it might be capacity, it could be something else. Now, this fixed and variable cost modelling, I did for years. I did it at General Motors, I did it at Elders IXL, and I implemented this system at DHL. They didn't do this. I remember my first day in the Middle East in Bahrain. So there I was, university degree, mullet haircut, not a three-piece suit, it's too hot, short sleeve shirt, and a pencil sharpened at both ends. Old habits die hard. And I remember the first day I looked at the profit and loss statement at DHL in the Middle East, and I go, oh, these idiots, they haven't split out the fixed and variable costs. So I got my pencil out and I went, labour, variable, rent of all their buildings, fixed, vehicles. And I thought, well, I'm not quite sure, and kept on going. And trying to assign a cost as being fixed or variable is not very satisfactory. It's pretty poor. And what we were doing back at General Motors, every month I'd get the production statistics and I'd multiply them by the variable costs. I'd add the fixed costs for the month. It'd take 2 weeks by hand to work out what the cost model said the cost would be for last month. I'll get the real costs from the financial account and then do variance analysis to say why the actual costs were different from what the cost model said the cost should be. And the explanation was normally some logical explanation. We used more gas in the furnace because it's winter and the ambient temperature is lower. It takes more energy to get the furnace up to a certain temperature. And if, the electricity was up in summer, it's because we had to run the air conditioners. Now, none of that was in the cost model, but that became the reason why we were over on gas or electricity from month to month, and that was the explanation. It was actually very rare that the explanation was poor performance. It was more than likely some reality of the way the cost behaved that the cost model didn't have in it. And I realised many years later, what I was doing all those years wasn't cost management. I wasn't helping manage the cost of the business. What I was doing every month was proving the cost model wrong, because 9 out of 10 explanations were perfectly logical. It wasn't in the cost model. So fast forward, I'm now the financial controller of Europe, Africa for DHL in Europe. This is mid-90s. And I've implemented that fixed and variable system in DHL across Europe and Africa, and having done it in the Middle East. And I was quite well known for it. I was the costing expert. And my boss, the finance director, called me in and he said, look, DHL has a policy of every year, every manager should spend 1 week on personal development and the company will pay for it. You could do a course or a seminar or anything you want, anything even vaguely related to your job, and it's a good thing to do. He said, Gerald, you haven't done this for years. And there's me thinking, that's because I'm so smart. I don't need to go and do seminars. I'm an expert. I'm a leader in my field. Don't you know that? So here I am, arrogant, ignorant, because I didn't realise things had moved on in cost management, and pretty complacent because I just thought I had my job completely under control. Arrogant, ignorant, complacent. These are words I use to describe many people in the mining industry, and I was that person, yeah? So he said, look, I've got this brochure came in the mail. There's a 1 week cost management seminar coming up in Paris at Fontainebleau, not at the Geostat school there. This was at the management school. He said, why don't you do that? And I said, look, I don't need to do that. I'm an expert in costing. I built our costing system. We've got this totally under control. I don't need to learn anything. Anyway, he pushed me, so I went. And I turned up, and that day one, Monday morning in Paris, I must admit I was full of attitude. I was like, oh, I'm here because my boss sent me. I don't want to be here. I know all this stuff. Come on, let's get it over and done with. And on that first day, the lecturer, who had a particularly annoying English accent, and the reason his accent was annoying is basically because I didn't like what he was saying. And it also came from the north of England, just like my father. But anyway, not that I don't like my father's voice, but I don't like being lectured to by anyone. And this guy, in one day, completely destroyed every principle I've been working to for the last 15 years. He proved categorically that fixed and variable cost modelling was not only a waste of time, it led businesses to dysfunctional decisions that sent them broke. And he had case study after case study, Harvard case studies that's proved that was the case. One day, he completely shattered my whole professional belief system, which is what I was trying to do to you guys yesterday, if you didn't notice. Anyway, I was shattered because he was right. One day, 15 years of career down the tube. I was like, oh, it's so clear. It's just like, how have I not seen this myself? I'll be honest, I didn't sleep that night. And I came in on the Tuesday morning. It's like, oh, well, what do we do now? And over the next 4 days, they taught us about activity-based costing, theory of constraints, and some other techniques that were actually made perfect sense. And I got really excited about it. So I rushed back to Belgium, back to Brussels, the following week, Monday morning. And I rushed into my boss's office, the finance director. And he said, oh, how was that seminar last week? And I said, boss, we got a problem. He said, what do you mean? I said, this fixed and variable cost thing we're doing, it's going to send us broke. And he said, you implemented that system. And I said, yeah, I know. And we have to change it all. So it was a bitter pill to swallow. And I'm hoping you'll swallow the same pill I'm trying to give to you yesterday and today and make a change. And I did. And it was tough to admit that what I've been doing for 15 years was actually dysfunctional. And my boss was great. He gave me a new job in charge of change management. And he gave me a $2 million a year budget, 6 staff to go out and roll out activity-based costing and theory of constraints around the whole of Europe and then Africa and then globally. And for the next 2 years, that's what we were doing. And so I ended up flying around the world doing presentations on activity-based costing, which is exactly what I'm doing today. So anyway, let me give you a 20-minute version of this, or 30 minutes. Just check the time. Sorry, before I get carried away. And we're looking for 11:30. Well, no problem. We're in good shape on time. So activity-based costing. So you have 4 different types of costs now, not 3. You have capital costs. This is the same thing, yeah? If you buy a new shovel or you put a second bore mill in or put some more leach tanks, you don't put the cost of that on the profit and loss. You put it on the balance sheet and you depreciate it over the useful life. You spread the cost out month by month, year by year, over 2 or 5 or 10 years. They're once off, and it's the cost of acquiring a certain piece of capacity. So you buy a truck. It's got a nominal capacity of 150 tons. It's got a nominal availability of 8,000 hours a year. Haven't used it yet, but that's and a larger truck generally costs more, and a smaller truck generally costs less. That's the capital cost. Then you have period costs. Now, this is what we meant before by fixed costs, in that they're related to the passage of time. But nobody said they're fixed. It's better to call them period costs, time-related costs. Now, these are the costs of maintaining availability of this equipment, the structure and the system that you've created, that you spent capital on. Now, a fixed cost or period cost, I'll use the word as often as I can, means that the system is up and running. Because you can say, oh, but if you close the system down, you avoid those costs as well. But we're not closing the system down. On the presumption that the system will be operating, there are certain costs associated with keeping the system up and available and operating that are period costs. They're time-based. So if you want to keep the system operating for 6 months, it costs so much. 12 months, it costs roughly double. 2 years, it's roughly 4 times that. And it's to do with the time. Whether you do more tons, less tons, doesn't make any difference. The availability of the system is a period cost. Now, it's better to call them period costs than fixed costs, because if you change the structure of your business, then your period costs will probably be different. Whereas if you say there are fixed costs and then you have to say our fixed cost changed, is a bit of a contradiction. Then we have attributable costs. Now, using the word attributable instead of variable is a much better word, because the trouble is this is what we meant by variable costs, but the trouble is if you say that's a variable cost, everybody thinks, oh, I understand that. It's a variable cost. Production goes up, it goes up. Production goes down, it goes down. But if you use the word attributable, you say that cost is attributable, you need to finish your sentence and you need to say that cost is attributable to, in other words, there's a cause and effect relationship that the reason this cost exists, the reason this cost goes up and down is because of something, and you have to name that thing. If you say that cost is attributable, everyone's going to say, well, attributable to what? And you've got to name the thing. And it might be production tons, but it could be depth, distance, density, fragmentation characteristics, whether it's above or below the water table. And when it gets in the plant, the crusher work index, the ball mill work index, the abrasiveness index, the density in the slurry, the pH, the melting point in the smelter, etc., etc., etc. And it allows you to build a cost model with much more accurate assignment of cost to certain characteristics of the process, or in our case, characteristics of the rock. Now, generally, this information exists somewhere in the organisation. You've just got to go and find it and then use it in the optimisation process we went through yesterday. Then you have another bucket called non-attributable costs. And these are costs that we spend, they're there, you can't ignore them, but they're not associated with today's business at all. And in mining, that could include exploration. We do spend $10 million on exploration this year. But it's not caused by whether we process or mine more tons or high grade or low grade this year. It doesn't make any difference to exploration. We spend money on exploration, research and development, marketing in some mining businesses, because we want to be in business in the future. It's not driven by today's production. It's driven by our desire to succeed in the future. So in activity-based costing, the capital costs go on the balance sheet, the period costs and the non-attributable costs, we do not allocate to anything. There's a terrible temptation in any cost modelling to say, well, this cost, what are we going to allocate that to? In other words, what are we going to divide it by? What's that per tonne or per ounce of gold or per pound of copper or whatever? And in activity-based costing, you do not allocate your period costs. You just say it's $30 million per year. To keep this system available and operating, it's $30 million per year. And if somebody says, yeah, but what's that per tonne of ore? You're saying, it's $30 million a year. You refuse to actually divide it by something. You say, what's that per ounce of gold? I said, no, because arithmetically, if you take any cost and divide it by a unit and then express it as dollars per tonne, dollars per ounce, dollars per pound, arithmetically, you are implying there's a cause and effect relationship. You're implying that if the ounces or the pounds or the tonnes go up and down, that these costs will go up and down by saying it's 20 cents per tonne or $2 per ounce. And so you've got to resist that. If there is a relationship and there's an attributable cause and effect relationship, you should divide it by whatever the driver of that cost is. But period costs and non-attributable costs, you do not allocate to anything. And it's a terrible temptation to divide. So where are we going to put this cost? The answer is nowhere. Oh, but head office, where are we going to put the G&A? Nowhere. It's $10 million a year for the head office. That's it. 10 million per year. The unit for period costs is time. That's the only valid one. So what I'd suggest you do to build an activity-based costing model, and I'm going to do one on the board in a minute just to show you how this can go, is don't go and see the financial accountant. Apart from the fact that particularly boring people, they have no idea why the costs go up and down. they can tell you very accurately to the cent what we spent on diesel and explosives and drill bits last year. Not in the project because you haven't bought anything yet. But they have no idea what makes it go up and down and no way of relating that to the ore body variation and things like that. So your management accountant, if you have one in your mining company, most mining companies don't have management accountants, then they may help. But the better thing to do is go and see the departmental managers. So you go and see the geology manager, the mining manager, the plant manager, the HR manager, the head office accountant, whatever, not the accountant, but whoever controls the cost there, and start with their budget. So just get this year's budget or next year's budget, whatever the latest version is, because the budget has been prepared by the departmental manager. And hopefully the budget's got some logic behind it. It's those budget work papers that is what you're looking for. So if the mining manager has, budgeted for $3 million worth of diesel next year, hopefully they've got some workings off the side that says because they expect to run two shovels at so many hours per year, and the consumption of diesel is so many litres per hour, and the diesel cost is 86 cents per litre, and they're going to run 5 drill rigs for so many hours at so many litres an hour. And so the reason that next year's budget is this much for diesel is because of those workings. Now, those workings are your cost model. If the budget is just last year's diesel plus 10%, that's a hopeless budget and it won't help you build a cost model. So what you do is take the budget, because somebody's already done some work on that, and go and have a chat. And I'm talking a 1 hour meeting, maybe maximum 2, with the mining manager. Let's start with the mining manager. And you talk and say, well, what do you do? What activities do you perform? Now, activities are not diesel, labour, parts, tyres. That's their cost inputs. The question is, what work do you perform? What are your activities? And in open pit mining, that would be drill and blast, excavate and load, haul, probably grade control, mine planning. Their activities, what do we do? And in the plant, it would be crush, grind, float or leach, depends on your flow sheet, filter, transport tailings, transport. Their activities, what do you do? Then you ask for each of those activities, and I'm going to do this on the board in a minute, just list some typical activities. Then you ask what drives those activities? What makes the cost of drill and blast go up and down from year to year? That's the context we're talking about for strategic planning here. And the first answer is almost always tonnes. They say, well, it depends on how many tonnes we're mining this year. So you ask a few more questions. Say, well, are all tonnes the same? I said, well, actually, no, because the free dig material near the surface, we don't drill and blast at all. So the drill and blast cost for those tonnes is 0. And then in the weathered material, we have a drill pattern of a drill hole every 12 metres, and the drill penetration rate is quite high. So the metres per hour is pretty good. So therefore the labour and the diesel cost per metre of drilling in soft weathered rock is quite low. And we use a powder factor of 0.6. You see where we're going? But when we get to the hard fresh rock, we have to do a drill hole for the blast every 6 metres, and the drill penetration rate is significantly lower than in the weathered material. So the diesel and the labour cost per metre of drilling in the hard fresh rock is going to be higher. And we use a powder factor of 1.2. Now that discussion, that's your cost model. And what they've just described is a basis for applying drill and blast costs to free dig, weathered material and hard fresh rock. And anything we can do to distinguish for all activities, not just drill and blast, all the activities through the plant and everything, distinguish how they apply differently to different types of material in the ore body, spatially, that's absolute gold. That's what we want, rather than just using an average. Now, I know you'll never mine just one type of material. There'll always be a mix. You'll never process just soft rock versus hard rock. But the blend is going to change, and the presumption is that the cost will be the sum of whatever the different cost components are. So it's a chat. And it's okay to use estimates. In an cost accounting system, using an estimate is completely unacceptable. If somebody estimated your salary, unacceptable. It's got to be right. And if we estimated what to pay our suppliers, that couldn't work. But this is not an accounting, this is not a purchasing system, this is a cost It's not accounting at all. It's a modelling system. So if you're talking, say, to the mining manager, let's stick with drill and blast, and the mining manager says, look, the drill penetration rate, so the meters per hour that you can do in soft weathered material is a lot more than in hard fresh rock. You say, okay, so what is the difference? What's the differential? And if the mining manager, looks up the stats and says, well, actually, we don't record that difference, so I don't exactly know. And you say, well, so what do you think? And if the mining manager isn't willing to give you an estimate of what the different penetration rate is in soft versus hard rock, and they probably can, then call in a drill rig operator. Call them in. Say, hey, Frank, you've been drilling for the last 5 years here. How much faster can you drill in soft rock versus hard rock? And Frank will say, I can usually go about 30% faster. You say, thank you. We're going to use that number. Now, that's not perfect, I agree, but it'll do. And it's better the old adage says it's better to be approximately right than be precisely wrong. And you can be too pedantic in this modelling exercise. We don't exactly know the difference, so we're going to treat them the same. That's completely wrong. It's better to use that 30% differential. And if that's a material difference, and it probably is, then it's worth adjusting your IT systems, your daily timesheets, to record the time and the meters achieved in soft weathered rock versus hard fresh rock. And then 6 months later, you've actually got some hard numbers and you'll update your model. But it's better to use an estimate in the short term. Now, that's what takes some confidence. This is not an accounting exercise. It's okay to use some judgment. It's better to be approximately right. And if it's a material assumption you're making, then change the system to get some hard numbers later. Then for every single activity, drill and blast, excavate and load, crush, grind, screen, whatever, leach, there is a major portion of the cost that's a period at fixed cost or non-attributable cost. And we need a method for actually splitting that out. And looking at the details of the cost and going fixed, variable, variable, fixed, it doesn't work. Although I did that for 15 years and made a living out of it, it's not satisfactory. There's another technique, and I'll talk about that in a couple of slides. And don't go overboard. For strategic planning purposes, what we were doing yesterday, yesterday we effectively had a 2-activity model, a mining cost, a processing cost. We can do better than that. If we got to, for a multi-billion-dollar business, 10 or 12 activities for the whole business, drill and blast, excavate, load, haul, whatever, crush, grind, screen, you get to about 10 or 12, that is magnitude better than what we had yesterday. I went to one mining company. I said, look, before we do any of this optimization, we need to build an activity-based costing model. They said, don't worry, we've got that under control. I said, fantastic. How are you doing it? They said, well, we've got, it was one of the accounting firms, Deloitte or PricewaterhouseCoopers, I can't remember. We got them in building an activity-based costing system right now. I go, fantastic. Will it be ready by Monday? He said, no, next February, which was 6 months away. I said, what are you talking about? Why is it taking so long? I wanted to knock it off this afternoon or maybe tomorrow morning. Not 6 months. How many guys are working on it? He said, we got 8 people here for 6 months. I'm thinking, no. How much are you paying these guys? It was like $2 million to build an activity-based costing system. I said, no. I'm not talking about that. I'm talking about having a workshop this afternoon and tomorrow morning. And we'll knock it off by the end of the week. To get to the sort of activity-based cost model we need for yesterday's purpose. Now, if you want to build this massive activity-based cost management system with 300 activities, well, I've done that. I'll leave that one alone. But don't get drawn into that sort of exercise for the strategic planning purpose. Yeah, leave that for another day. So we're talking about a couple of workshops, and I'll show you one in a few minutes. So here's another point. It's very easy to cost what I've got here. The words are the frontline activities or the direct activities. This is mining of waste and ore, milling of ore. This is Monaro Resources. So high pressure leach of the ore to refine nickel and cobalt. These frontline activities or the direct activities are relatively easy to cost because there is a direct physical relationship between drilling, blasting, excavating, hauling waste and ore. Cost models get really, and we tend to gravitate to those because that's the interesting bit. Cost models get very poor when we get to the more intermediate or support activities, or you could call them frontline and backline activities, or you can call them direct or indirect activities. There's many words for this. It's the things that are removed from the physical cost objects, waste, ore, nickel and cobalt. Now, in the Monaro Resources, they have a utilities department because they import sulfur, they burn it to produce acid, which is about 30% of the processing cost. And in the process, there's a lot of heat and steam produced. Some of the steam is used to preheat the autoclaves. Some of the steam turns some turbines to cogeneration some of the power. They also have a gas pipeline, and they run some big gas turbines to produce the rest of the power. Now, the problem with cost modelling is, and you normally focus on this bit first so you're getting weary, is you go see the utilities manager with their budget. You say, oh, okay, $40 million this year. Wow. It says, what does that cost per tonne of ore? Now, the problem with that question is it's the wrong question. And the problem is they'll probably answer it. They'll mentally take their dollars, divide it by the tonnes of ore, and give you an answer. But it doesn't mean anything because the utilities department doesn't touch the ore. So to take their cost and attach it numerically to the amount of ore, whether the ore goes up or down, is particularly inappropriate, it's particularly inaccurate. They can tell you very accurately the cost of acid, power, steam, and calcrete. You can flow that through to see, well, where is the acid consumed and what aspect of the ore consumes the acid, which is the nickel, the cobalt, the magnesium grade, and the steam and all those rest of things, and flow it through to get it to the cost object, waste, ore, nickel, cobalt. But you can't go direct from here to here. It's too inaccurate. So you've got to be careful what questions you ask because it sounds like a reasonable question. And the trouble is somebody will answer it. And just because they answered it doesn't mean it means anything. And it gets worse. You go to the HR department. You look at their budget. You say, what does that cost per tonne of nickel produced? They'll answer the question, but they don't touch nickel. They can tell you very accurately the cost of supporting fly-in and fly-out people. Maybe, management versus blue collar. You can flow that through. And I'm talking about still in this year's budget. And charge and load up the costs of all the people working in the different departments according to whether they're fly-in, fly-out, blue collar or management. And then attach the costs onto the cost of mining waste or producing nickel and cobalt. But you can't go from there to there in one step. It's too rough. And so you've got to be careful what questions you ask and try and get a cause and effect relationship. Then you're going to go through each of these activity groups and you're going to split out the period costs on the basis I'll go through on the next sheet. You can't just go fixed, variable, variable, fixed. That doesn't work. And so a major portion of the cost is going to end up in this bucket down the bottom. It's not allocated anywhere. It's only the variable attributable cost that you attach per tonne, per cubic metre, per drill metre, per whatever, some physical characteristic. The rest just goes in this big bucket down the bottom, which is your period costs and any non-attributable costs, and that's expressed per year. So how do you split out the period costs of any activity group if you can't actually say that cost is fixed and that cost is variable by looking down the list of costs? So the recommended approach is this. Now I'm going to treat on this graph mining as if it's one activity, just to keep it simple. But mining is not one activity. Open pit mining is probably 5: drill and blast, excavate, load, haul, mine planning, whatever. And so, and grade control. You do it actually activity by activity, but let's just say mining is one activity. Now you've got to do this sort of analysis for what's called the relevant range of activities. And yesterday we were talking about a maximum mining rate of 60 million tonnes. So that's the top end of the relevant range. And at times we were parking half the fleet. It was dropping down to about 30 million tonnes. So the relevant range that we want to have a cost model for is between 60 and 30 million tonnes. Now, in the last case, we expanded the fleet to 83. That's okay. But let's just go 30 to 60. If you actually want to do 150 million tonnes, that's a different scenario. You'd use different equipment. There'd be economies of scale. There'd be all sorts of things. And if you actually in 1 year we're going to drop down to only 10 million tonnes, you would mothball some equipment. You'd do something different, yeah? And we're not asking those questions. I don't believe it's possible to have a single cost model that'll work for such a wide range. We want a cost model that's good for the relevant range, which is between 30 and 60. 100% utilisation or whatever the maximum is, and roughly 50%. In an open pit, that range would be normal in an optimised plan. So we start at the top end. We say 60 million tonnes, because this is not analysing a business. This might be a project. We haven't even got a business yet. You say, well, what would it cost to mine 60 million tonnes in this particular location? And you do what's called a zero-based budget. Zero-based means it doesn't start with anything. You just build it up from scratch. So you'd say, well, we need 2 excavators. We need 8 dump trucks of a certain size. We need a large bulldozer. We need 3 mine planners and, whatever. And you see what it would cost, and they're going to be working at maximum, 95% or whatever utilisation, whatever your maximum is, 90%. And you could add up the capital costs and you could add up the OPEX of running that fleet at, full utilisation to achieve 60 million tonnes mining in the year. That's that number there, $110 million on this graph. You then ask a second question. You say, okay, that's fine. That's our full capacity. What would it cost to mine only 30 million? But be careful with the question, because if you just ask that, then you'll end up with 1 excavator, 4 dump trucks, a small bulldozer. But that's not the right question. You've asked the question, what does it cost to mine 60 million? You say, what does it cost to mine only 30 millions whilst maintaining 60 million tonnes of capacity? Because if in 1 year we only mined 30 million tonnes, which happened all the time yesterday, didn't it? You're not going to get rid of equipment because you might need to do 60 again the year following. So you're going to stand down, you're going to have, say, roughly 50% utilisation of the fleet. So the question is, what do you actually save? You're not going to get rid of any equipment, and you may not even get rid of any people. Well, you might. That's a big question in this equation. In over a 12-month period, can you actually get rid of people and get them back again a year later? And if you can, then it's variable. If you can't, then it's fixed. And so you will save, obviously, some diesel, drill bits, explosives, wear on the tyres. So some of your maintenance costs, but not all your maintenance costs. You're still got to maintain these trucks, even if their utilisation is only 50%. So it's called the subtractive method. You start at the top. What does it cost to mine 60 million at full utilisation? And the second question, what do you actually save if you only mine 30 million in one particular year, whilst maintaining that 60 million capacity, because you might need it again the next year? So you work back from the top. Then you do draw a line through here, and you end up with a cost model for this particular activity, which is, the y-intercept is effectively the underlying fixed costs, period costs. It's $20 million a year, and the variable cost is the gradient of that line, $1.50 per tonne. Now, I know it probably goes in little skips and bumps. It doesn't matter. This is a lot better than what we had yesterday. What we had yesterday for a mining cost was, I can't remember the number I used, $2.80 or $3 per tonne, which was the fixed and the variable cost divided by tonnes, which arithmetically told the optimizers that it was 100% variable, because we said $3 per tonne. So when Millaway yesterday was parking half the fleet, it was thinking it was saving half the mining costs. And we know that's not true. You will save some costs by parking half the fleet, but you don't save all the costs, because some of the costs are a fixed or period cost, but we didn't split those out yesterday. Now, the optimizers I used yesterday are ruthless mathematical optimizers. They'll behave to whatever you tell them the truth is. We've got to tell them the truth. So we need to put into our model yesterday, not that it's $3 a tonne. We've got to put in that it's $20 million a year and it's $1.50 a tonne. And the optimizer yesterday, whether you're using Proba, Simo or Millaway, whatever you're using, will go, oh, in that case, I won't do this mining pattern. I'll do something else. Now, that's closer to the truth. Now, if labour was variable in your location, which it may well be, then you'd probably get a curve like this with relatively low period or fixed cost component. But if you're in a location where labour is fixed, which in some locations it really is, you've got no flexibility. If you do park half the fleet, then you can't send half the people home, or any of the people home. You've got to keep them on doing something, preferably not driving trucks around. And in which case you get a very different relationship. The top number is identical. It's a question, what do you save if you drop to 50% utilisation? You'll still save diesel, drill bits, explosives and wear on the tyres, but if you don't save the labour, you're going to end up with an equation more like $50 million a year, not 20. And the variable attributable component, the incremental component, is only $1 a tonne. Now, the optimizer yesterday, you put in $3 a tonne, you put in $1.50 a tonne plus 20 million, or you put in $1 a tonne plus 50 million. It will behave differently. Those tools I've used yesterday and the other tools in this area are ruthless mathematical optimizers. We need to tell it the truth. Is that okay? So that technique, and it takes some estimate. It's not exactly right. It doesn't have to be exactly right. It needs to be about right. But this is magnitudes better than what we had yesterday. And it changes everything, frankly, as you can imagine. So this is the first activity-based cost model I built in mining back in 2002 or 2003. It's Manara Resources. I did change the numbers. They're about right, but that's that long ago. Confidentiality is irrelevant. And so we ended up with 10 activities: mining waste, mining ore, hauling, reclaiming, milling, and what they call a mill is just a simple crush and screen. It's not a ball mill. And then acid is a big component. Calcrete consumption, the leaching, refining of metal, and that's it. There's 10 activities. The costs that are attributable, variable, incremental, do get divided by the units of whatever the relevant cost driver is to get these cost factors. So waste mining is $1.94 per wet tonne. Ore mining is $2.81 per wet tonne because they use a higher powder factor, more close drilling, and they have more intensive grade control and more selective mining. That's why the cost of mining waste is less than mining ore. It makes sense, et cetera, et cetera, et cetera. And we end up with a situation where, and the green is the period costs, and this we just express per year. Now, this is still analysing that year's budget. We haven't gone anywhere with it yet. And if you add up all the period costs, you end up with 108. So the total cost is 409 million, of which 181 million, so 45% of the total annual cost of the business is a period cost. It's not going anywhere. You could do more tons, less tons, high-grade nickel, low-grade nickel, high waste stripping, low waste stripping, whatever, and 45% of the cost is just there, not going up and down at all. It's a period cost. Now, if you close the business down, that goes away as well, but that's not what we're contemplating. So 45% of the cost is a period cost, and the attributable costs, they're the ones that do go up and down according to these formulas. Now, what you do is you square this off, reconcile it, make sure it adds up for this year's budget. Then a good test is to apply it to last year's costs and see how well this model explains what the actual costs were last year. And you might say, oh, actually, no, we need to adjust this a little bit. And then once you've got confidence that this model is about right, then you can apply it to next year, the year after, the year after, the year after, in terms of in your strategic planning process, and have confidence that it's pretty right. Now, it'll never be perfect, but it's an awful lot better than what we did yesterday, where we just had a mining cost, a processing cost average, and effectively by unitizing it, treating it as 100% variable. Does that make sense? It's just applied common sense. That knowledge exists in the organisation. You just got to go and find it. It is not a 6-month, $2 million exercise. It's a handful of workshops over 2 days to get to something that's good enough to support the integrated strategic planning process I talked about yesterday. Now, what I'd like to do is I'd actually like to take a break. Can we do that now, Stephanie?
We can.
Let's take a 15-minute break now. And when we come back, I'll go through just 5 minutes on open pit and probably the mill on the whiteboard. I'll get it set up just to show you what an activity-based costing workshop looks like. And I think you'll see what I've been talking about, how much sense it makes. So let's take our 15 minutes. I'll see you shortly. Any questions too, I'll answer at that time.